Hi guys, this is the first lesson in Unit 6, and all through this unit we're going to be looking at different applications of the derivative. So the first application that we're going to look at is displacement, velocity, and acceleration. I think velocity is probably the one that will make the most sense to you based on kind of real life knowledge, but we'll also kind of move into talking about acceleration with that. So basically, we're going to be using calculus to study motion. And in this course, we're only going to consider motion in one dimension or along a straight line. So objects that would be moving back and forth or up and down in only one direction. So the motion is along a straight line. And that could be horizontal or vertical, just kind of for standardization sake. If we talk about a horizontal line, we would assume that the right, moving to the right, would be moving in a positive direction, and moving to the left would be negative, just kind of like our x-axis when we're graphing. And if we were talking about a vertical line, we'll assume that moving up is in a positive direction and moving down is in a negative direction. And again, that is kind of arbitrary. Obviously, any straight line movement could have a positive or negative side given a reference point of 0 or origin for that, but we kind of refer to it as up, down, left, and right most often, but it could just be along any general straight line, and we just reference the positive direction or the negative direction. If it's a horizontal line, we will assume, unless we see otherwise, that the movement to the right is positive and movement to the left is negative, and likewise for the up and the down in a vertical line. Okay, so we've got a position or displacement time graph here, and looking at this is actually kind of goes back to what you guys would have looked at in grade 9 when you were very first learning about slope. And in grade 9 we talk about these movement graphs as we talk about steeper slopes of the line means that somebody's walking faster, and where it's horizontal, that means it's a slope of 0 and the person's standing still. So these should be pretty familiar from a few years ago. Just want to make a little note about displacement versus distance. So displacement, this is distance with a direction. So that's the absolute distance that you are away from the 0 or the origin. And it's not necessarily just like 5 meters, but it would be 5 meters north or 5 meters to the right. So it's kind of similar to what we talked about with vectors versus scalars as well. So if we were looking at this, what's happening in this graph between 0 and 10 seconds. So we know that between 0 and 10 seconds, the object is moving 60 meters in a positive direction in a 10-second time period. So this would be moves 60 meters, and I'm just going to say right, assuming kind of a horizontal movement here. And we can say that the velocity or the speed there is 6 meters per second because it goes 60 meters in a time of 10 seconds. Between 10 and 15 seconds, so that's this little piece of my graph here, we see that it's at 60 meters away and then it's still 60 meters away. So that's a stationary or not moving. Because the position of the object stays the same between that 10 seconds and 15 seconds. The next segment of the graph, so between 15 and 30, so that would be along here, we move 60 meters again, but now it doesn't it doesn't take just 10 seconds, it's a longer time. It's from 15 seconds to 30 seconds. So you've got a 15-second time span. So they're moving slower here. So this is moving more quickly away from the origin to the right. This is staying still. And then this is moving back towards the origin, moving in a negative direction, moving to the left, but at a slower pace. So this we could say moves 60 meters left, which is going towards the origin, and the velocity there would be 60 over 15 or 4 meters per second. So it's a little bit slower than the velocity when it was moving away. I think that you guys will probably remember that the slope of this position time graph tells us the speed. And especially for kind of a segmented linear graph like this, I think that that's pretty easy to see. So the slope tells us, now we used to say speed, but we don't just have distance here. We've got displacement, which is distance with a direction. And just like displacement is a vector quantity, we've got a vector quantity that is kind of corresponds to what we would call speed, and that's velocity. So this is the velocity of the object, which has a magnitude and direction. So the velocity is the slope of the displacement graph at any time. So here, actually, if we are looking at velocity, this would be negative 60 because it moves 60 in the negative direction, and then that would be a velocity of negative 4. So it would be a speed of 4 meters per second. We were just kind of comparing how fast the object was going, but it would have a velocity of negative 4. So we can say what we usually refer to is speed in kind of real life situations. That's the absolute value of velocity. So, or the magnitude. So speed only measures the magnitude. Velocity measures the magnitude and the direction. So whether it's going in a positive or negative direction. The last thing I want to look at in this video, and I will do kind of subsequent videos for later parts of this unit or this lesson, is a velocity time graph. And this is a little bit harder, I think, to kind of visualize what's happening. So initially, we've got this, and this is velocity. So I'll label that V at T and T, and we'll kind of assume meters per second. So here we've got a velocity of negative 3. At the initial moment, the velocity of the object is negative 3. The velocity is changing here as we go through these first 2 seconds, say in this little segment of this graph. The velocity is negative 3, then maybe negative 2.5, negative 1, and so it's slowing down. So between 0 and 2 seconds, velocity is negative, so it's moving in a negative direction. It's moving to the left or it's moving down, depending on whether we have a horizontal or vertical movement. We can just kind of assume that we've got this horizontal. So the velocity is negative, it's moving to the left. And it's slowing down. And we're going to come back to this later. It looks like velocity is increasing, right? We would look at this and say, oh, well, we have a graph here, and obviously this function is increasing through this segment. But if we're talking about speeding up, slowing down, we're looking at the actual speed. How fast is the object moving? It's moving less fast here than it was here because the velocity here is negative 1 and the velocity here is negative 3. So looking at the magnitude of the velocity, that has decreased. And that's what we're talking about with speeding up or slowing down. Okay. At this point, so here at 2 seconds, the velocity is 0, just for an instant. So the object is stationary just for an instant. And then we can look at the next segment of this graph where it's going from 2 seconds to 3 seconds. So here the velocity is positive. It's moving in the right hand, moving to the right. And the velocity starts as small positive. Say there the velocity is 1. Here the velocity is 2, then it's 3, then it's 4. So velocity is positive. So a positive velocity means movement to the right. Or up if you had a vertical line. And it is speeding up. It's getting faster and faster. Now, between 3 seconds and on, kind of separate this out a little bit. So say even from 3 seconds to 6 seconds, the velocity here is staying positive. So it's still moving in a positive direction that whole time. It looks like the velocity function is decreasing, but it's still positive. So this object is moving in a positive direction, but getting slower and slower and slower as you change from 3 seconds to 6 seconds. So the velocity is positive. And the speed is decreasing. So it's moving to the right. And if we talk about speed, which is the magnitude of the velocity, that is decreasing. So it's slowing down. So what this might look like if we kind of picture what this object might be doing, if this was kind of my motion, kind of follow the eraser on my pencil here, from 0 to 2 seconds, it's moving to the left, but it's slowing down. So it starts off moving pretty quickly to the left, but then slows down. At 2 seconds, it stops just for a second and then starts moving to the right, speeding up, speeding up, speeding up, and then slowing down, slowing down. It's still moving to the right, but by the 6 seconds, it's going really slow. So it starts off again, moving to the left fast, but then getting slower, slower, slower till it stops, and that's at the 2 seconds. Then it starts moving to the right slowly, speeds up fast, then slows back down, still moving to the right.